Hello everyone. Today we are going to discuss about resistors in series connection. Not only for 10th class, in higher studies like in engineering first year, basic electronics, it is common for all the branches. At the same time, for SSC also it is very important for 4 marks. What is the equivalent resistance when resistors are connected in series? In 3 ways they are going to ask this question. Derive the expression for the equivalent resistance of 3 resistors connected in series, or derive R equivalent is equal to R1 plus R2 plus R3. Sometimes in the place of derive they use the word deduce the expression for equivalent resistance when 3 resistors are connected in series. And you all know that series connection is nothing but, if we apply this series connection for in cells, the positive terminal of the first cell is connected to the negative terminal of the second cell, and the positive terminal of the second cell is connected to the negative terminal of the first cell, like this. Series connection means, so we all know cell contains two terminals, negative terminal, positive terminal, negative, positive, negative, positive. So in series connection, the positive terminal of the first cell is connected to negative terminal of the second cell, and positive terminal of the second cell is connected to negative terminal of the third cell. To understand the meaning of series connection, I am explaining by taking cells. That means group of cells is called a battery. In battery also we are arranging series connection of the cells. So in exam no need to write this part. Our answer is deriving expression for equivalent resistance, that is R equivalent is equal to R1 plus R2 plus R3. So in series connection, if we observe, means when the resistors are connected in series, there is only one path for the flow of electric current I in the circuit, so that we take current as I, and according to Ohm's law, Ohm's law is nothing but the potential difference across the conductor is directly proportional to current. By removing that proportionality constant, we got the relation V is equal to IR. Here we apply this Ohm's law. If we apply this Ohm's law for this circuit, here V1 is there. So according to Ohm's law, V1 is equal to, general formula is V is equal to IR, but in our situation V1 is equal to I into R1. V2 is equal to I into R2, and V3 is equal to I into R3. Let R be the equivalent resistance and also V is equal to I or equivalence, because we want to find equivalent resistance when 3 resistors are connected in series. So V is equal to I into R equivalence, and voltage V is equal to V1 plus V2 plus V3. V is equal to V1 plus V2 plus V3. So already we know V value is I into R equivalence, and V1 means, already we wrote V1 is nothing but equals to I into R1, and V2 is equal to I into R2. V3 is equal to from this diagram I R3. So on right hand side current is common, that is I. R1 plus R2 plus R3. So this side I are equivalents. So on both sides current is common. So we can cancel this current. By cancelling we get equivalent resistance is equal to R1 plus R2 plus R3. This is the expression. From this expression what we can conclude? The sum of the individual resistances R1, R2 and R3 are equal to the equivalent resistance. The sum of the individual resistances R1, R2 and R3 is equal to the equivalent resistance when the resistors are connected in series. That's it.